Good day. Welcome to the Iconics webcast. We will be presenting a series of different and interesting topics, so please stay tuned for further information on upcoming webcasts. Today, we will be presenting on the topic of MQTT basics. Here, we have our team from Iconics APAC, led by Dr. Habib Rahman and consisting of Ms. Amanda Koh, Mr. Sutipong, and myself, Indra. I will now hand this over to Dr. Habib, who will kick off this webcast. Dr. Habib, please.
Thank you, Indra. My name is Habib Rahman. I'm director for Iconics Asia Pacific. Iconics has been providing software for automation software for many industries, including building, oil and gas, water, wastewater, manufacturing, process control, and many other industries. The power of Iconics software is that where it focuses on operational matters, production, and the plant floor. It also provides us a great and powerful link to IT side of the applications as well. And it brings data back and forth from both operational and IT into one user interface. And that's where the power is. And we're going to be discussing how we can combine both of the words into one single unique interface, and that is Iconic's power. That's basically done through following the industry standards using OPC UA, Modbus, SNMP, JSON, HTML, MQTT, BACnet, and the power of SQL as well. So using these industry standards like CC Link, we bring all those powers into the system architecture. If we look into the system architecture, we have got this bottom layer, which is what we call it the universal connectivity. And that's the start of the power of connectivity to the controllers, industrial controllers, PLCs, IoT devices, IT applications, databases, web services. All those source of information, field instruments come into a centralized platform service, we call it frameworks. And within the frameworks, we have several other applications and services to contextualize and provide security and normalize the data, and then provide to specific modules and applications, what we call them alarm management, data history, dashboards, trending, logging, and so on. And then after processing the data into useful information, providing that into the client technology like the desktop, mobile, web interfaces, and so on. So looking into the data connectivity, we have a tool when you install Genesis, you have a tool called Workbench, and the right screen capture is for the Workbench where you would see all these tabs where you have the data connectivity and you can connect to BACnet without requiring any third-party OPC servers, connect to databases, Mitsubishi Electric FA connector, we call it Factory Automation Connector, the PLCs, controllers. Modbus connector is built in SNMP, so you can scan all the devices, Ethernet devices that support SNMP protocol, and build your web service APIs as well. Now, with the Internet of Things, we have also added connector for MQTT. So today the topic is basically how we're going to connect to those devices that publish data or that comes with MQTT protocol support. And we're going to be looking into what do we mean by publisher, subscriber. So that's our topic of discussion. And for the technical help today, I have invited our technical resource, Amanda Koh, and she's going to be joining this session and giving us a little bit more insight about MQTT. How do we, what it covers, how do we connect, and a little bit more talk. Please join us, Amanda.
Hi, thank you, Dr. Habib. This is Amanda. So,
Thank you, Amanda, for
yep,
joining. So tell us a little bit, what is MQTT and what's the background and how can we use? So we would
yeah,
appreciate your time today with us. Yeah.
yeah, I appreciate too. Thank you. And MQTT is the standard for IoT messagings. It provides the protocol between the messaging protocol between devices and applications where the data is being published in a very, very small packet. It is very lightweight, right? And lightweight in terms of connectivity and coding because it's very small bandwidth and it won't be overloading, right? Overloading will not happen. So how do we send data? So you may ask me, can you provide example? Of course, sure, I will provide example. But before that,
Yes.
yeah,
So we want to know how we get the data from devices, IoT
mm,
devices, and how can we send our data to third party using MQTT. So tell us
yeah,
how can we receive data and how can we send data in two different instances. Yeah.
yes. I would like to give an example shortly. So over here, it is a very simple architecture that you may see that in iconic applications, the iconic Genesis 64 can be in the cloud, can be also resided in the local premise, right? And it needs the data to be gathered from all around the network system and also devices. So there are many ways you may use client-server communications to directly connect to the data sources, or you can use the publish subscribe method through messaging handling middleware, which over here we talk about MQTT brokers. Okay? And before I go on to show the example, I would like to have a quick touch on our next webinar topics called web services. So web services can expose some of the data like weather forecasting information that you're familiar of, prices from some resources or some third-party data source. And using this HTTP protocol, data can be periodically requested, read from, or returned into the web services using this RESTful API. Uh, yeah,
So that's
information. Yep.
so RESTful API is another alternate method apart from MQTT for publishing and receiving data. So that's the topic we will discuss in
Mm,
another session. So let's focus on MQTT today.
okay. Yep. So I have put up an example that we have worked with partner called the Evercom. So Evercom is a company that provides the carbon emission reports, helping customer to generate those certified certificate for this carbonized um, reportings. And in this example, you can see the screen here. We maybe we would like to get some data from some IoT devices, could be from sensors, temperatures, or could be from power meters. So this testing, we have getting some power consumption data from power meters, and we use the local IPC having Genesis installed, and we publish the data using the workbench, setting up the data publish into this AppCom using the MQTT broker. And once the data being processed by AppCom, they can actually send back to us, or rather, our Genesis will subscribe to them to get hold of the data that's being processed. And Genesis also, we can present the data in the graphics in the dashboard format. So over here, this screen is a quite simple, whereby simple but yet details of illustration of data that's being monitored under Genesis. So having all the parameters, kilowatt hour readings being monitored, and also having the data being processed by Evercom using their MQTT broker. They send us the carbon emission data after their calculation, and we use our Genesis graphics to display them. So we can see the read, and we can see or rather, we can see the data we send out. We can see the data that's being received through this MQTT. Okay, I hope that this is clear illustration?
Yeah, that's good. Yeah, so basically we collect data from PLCs and controllers, and with MQTT broker, we publish this data to third party, and they have their own application for doing some machine learning and doing some analysis, and they make some results, and we can use those results back through MQTT as well as web service back into our applications and in our control. So yeah, that's a good one.
Mm-hmm.
So tell us a little bit more. What do we need to do and how we set it up inside, and what is required?
Right.
How much expertise and how much knowledge is required to do all
Yeah.
these things?
Yeah. So in Genesis 64, we have this data connectivity that allows you to connect to many open industrial protocol, which Dr. Habib mentioned earlier on, things like OPC UA server, SNMP, web services, and of course MQTT broker that we are, more concerned about today. So IoT device can publish data, right? So IoT device can be from sensors, can be from actuators, can be from machines, and the data can be published in the JSON format. It's very lightweight. Can be data in the chain format or binary format. And a client like Genesis 64, we subscribe to the broker, and we will make use of the data that we receive, just like the earlier sample that I showed. Now, so what is MQTT broker? It is a server that receives all the messages from the clients, and then it will route the message to the appropriate destination clients. So the next screen here is a very simple screen that showcase of the sensor IoT device, such as sensors that's published to the broker, and then we can use the Genesis to do the subscriber to get hold of all the data in the dashboard.
So if the IoT sensor, for example, temperature sensor or the power meter, is already publishing data to third party MQTT broker, then and we want to get this data to Genesis, we can just subscribe
Yes, correct.
to existing broker and we start getting data. And if we want to publish from Iconics, then we can do that as well. That's good.
Yep. Okay, this slide here is talking about the publish and subscriber communication models, right? So it's actually this model is separating the consumers from the publishers. So the publisher will send message to the middleware, the MQTT broker, and the publisher will not need to know who or how many subscriber is subscribed to them. And publisher will also needs very, very little resources. Then message that's being distributed to the subscriber also doesn't need to know, right, who is a publisher. And it's very scalable, can be scalable to many, many publishers and many, many subscribers.
So that means that we can use the broker as a firewall or cybersecurity measure as well, that we want to separate the source of data to the client as well as we want to only limit what we want to expose to the outside world.
Yes.
Instead of exposing all the data sets or all the data points. We may have many information, but we just want to show only one data point or the total production to the clients. So that's a very good way of doing one-way communication from data source to the client, like data diode kind of thing and the firewall kind of thing. That's really good, Amanda. Yeah.
All right. So how does MQTT transfer data? I mean, what kind of data they transfer? So it could be in bits or bytes, strings, images, and so many others, right? In Iconics, our solution we stay focused on JSON. JSON will encode the message. So in order to find a very common structure to express the state of the device. And this information we would like to organize in a hierarchy called topics. So when publisher has some new item of data that they want to distribute, they will send a control message with the data. to the connected broker. The broker will then distribute information to any client that have subscribed to that topics. So from there, publisher doesn't need to know to have any data on the number or locations of the subscribers. And the subscriber also in turn doesn't need to know to configure any data about the publishers. So it's very clear cut between them.
So, Amanda,
Yeah.
tell me, I mean, how much expertise do you need on the JSON programming thing, So do you need a lot of years of programming experience, or it's very simple?
I think it's not difficult because I'm not a very programming savvy person, and I can do that. So you can do that.
All right.
Everyone can do that.
Okay, share your experience with
Yeah.
us. What do you do? Yeah.
Yeah. So over here, right, we need topics. So what is topics? So topic is basically an address where a message will be sent to. Okay, and it can be consist of one or more topic levels, and each of the topics is separated by a forward dash slash. Okay, and the topic can be in very logical name, or it can be in the tree structures, and they are being separated by characters or forward slash, and they are also case sensitive. Okay, so the client typically subscribe to specific topics, okay, and any collection of topics. But bear in mind that the client will not be encouraged at all to subscribe to the root. So because if you were to subscribe to the root with this type of a wildcard, so there's a lot of message that the client will get, which is not necessary for them. So over here, when we say we subscribe to the topics, we can use wildcard filtering. So we can use a hash, or we call this a pound, to filter child topics. Okay, so it means we want to get the data from the childs, or we can use a wildcard to filter particular single level. The next slide, you will see some example of what I meant. Okay, so here on the right side, you see this is the data that is coming from the MQTT brokers. Okay, so if we were to subscribe to just want to know this particular sensor, so we need to be clear of what is the wildcard that we want to use. So over here, we can see that we have data coming from temperatures and giving us some timestamp information. So let's see.
Okay, so that's good. So it's a simple format. So give us
Yeah.
a little bit more how this is structured and how this is set up. So if we want to have single value or multiple value,
Yeah.
what do we need to do?
Right. So, message can contain one value in JSON message, or can be multiple values. So, about one value for each message. This is the example. So you can see in one message, you still will see the ID, which is called palm1, or the value which is coming, the real-time value is 1. So this is one value for each message. So they can also choose to get the data from multiple value in value arrays. So this is one data from a sensor. So the second one from another sensor, and the third one from another sensor. So this is we call multiple value in value arrays, right? And it is good to actually receive the quality data of the sensors and also the timestamp. Why is that so? Because having this quality and timestamp, we can use it to monitor under our alarm. Okay, our alarm management, we can see when does this happen. So this is, it's not necessary, but we would suggest to have this quality and the timestamp be included in the array. I mean, in the message, right? And of course, timestamp by default, is always in UTC format, so we can always make changes during our encoder inside our encoder, right?
Okay.
Yeah, right. So, in Genesis 64, we use Workbench to do a lot of configuration, application setup. So for the broker, is in this location, under IoT. So we have things like a MQTT broker where you need to create a broker name, so far and so on, or the setup. you can create a subscription connection, and also you can customize your encoder decoder. Okay, so this encoder will define what is the expected format of the message that you receive. Of course, you can choose to use the default Iconics JSON, or you can choose to use your own decoder. Yeah.
Right. So basically, the setting in the broker would make the connection if you are receiving data or if you're sending data, like we use the word or terminology subscription and publishing,
Mm.
and encoder would decide what is the format,
Yes.
how it is being received or sent out.
Yep.
Okay, so give us a little bit more how we're going to do it if we have to go into Workbench. Where do we go first, and
Yeah. So
what are
this
the
is what,
steps? So,
yeah, what I like
oh,
to show.
okay,
Yes.
all right, that's
Uh,
good.
yeah, in fact, later on, after my session, my slides, my colleague Sudipong will be giving the actual demonstration, but I would like to
All
give a
right.
glimpse of the setup first. So over here, I have a few steps. So first step, we need to create the MQTT broker, right? So we give a reasonable name, and we choose the protocol, which is simple MQTT, and the server address. Look, the MQTT broker can be installed locally in the local PC, or if the broker is resided in the cloud or in other premise, so you need to enter their IP address or their computer name. So wherever the broker service is running, right? Yeah. So this is very flexible. Not necessary to be in the local PC. Can be in from you know the party
Right, and
location. Yeah.
right, and I can see that we're not going to discuss in this session, but I can see that there are other topics which are included inside the
Mm.
configuration of the security and the
Oh
certificates.
yes,
So
correct.
yeah, so that is basically to secure your data that nobody without the authority and the authentication comes and start collecting and
Correct.
getting data from the
Correct.
broker.
Correct.
So that part we just leave it for another session probably.
Okay. Yes.
Yeah. Okay. Good.
Right. So over here we created the broker, and remember I mentioned about a publisher. So we would like to publish some data that is collected from Genesis. So we
Mm-hmm.
monitored some device from some sensors or kilowatt hour from power meters. So these are the data probably we want to send out, publish out to the broker for them to do some of their processing. So this is
So
the
if we
application.
have
Yeah.
so if we have some Modbus
Mm.
PLC data and we want to send it to third party,
Yep.
these are so we select these
It's
Modbus
possible.
registers.
Yes.
Okay, all
Yeah,
right.
can be from OPC UA server data, can be from
Mm,
Modbus, can be from
okay,
PLCs.
okay,
So we configure to send the rhythm data with the timestamp. So that's the
okay.
second step, right?
So that's what we are exposing. That we are only exposing these four tags to the
Yeah,
outside world. All right,
right.
good.
So the next step, so this is where we create the publisher. So we give a name, of course, and then we will choose what is the encoder. Do you want to use your Iconics JSON default encoder, or I would like to use a separate encoder that I may create later on. Okay, so this is you need to select, and you select the publish list that the previous second step was shown, a publish list,
Mm-hmm.
and also the choose the MQTT broker that my first step, MQTT broker, and the topics. So what is the base topic in this hierarchy? So it's my ICO next. So this is the topics that you set up first. Yeah. So let's say I choose to create a separate custom encoder. So I will go to my encoder, create a name, and then I will use the uh, custom JSON as a plugin. And the message type, there are a few. I remember there are about 4 types you can choose. So things like multiple values in the values array of the message, or one value per message. So there are two
Mm-hmm.
more, I think. Yeah. So you can set up the topics, the values. In fact, you can put in the quality and the timestamp within this as well.
Okay. So that's where you would put up the syntax
Mm,
what you want to publish. Yeah.
yes, correct.
That is the JSON format.
Yes, that's a JSON format. Yeah.
Okay,
So
that's
let's
good.
say I want to use my encoder, so I move back to my third step. So I just change the iconic JSON into my encoder. Okay, the rest will be still the same. Okay. And after we configure, we started all the services. We would like to see the verified the connection, right? The published connection, the subscriber. So we have two methods. You can either use Iconic's built-in Data Explorer app to see, to verify, or you can download from the internet, from the website, a free download called MQTT Explorer. Okay. So here is a sample screen that shows Data Explorer from Iconics. So how do we view to verify? We have to choose the Internet of Things from My Computers, and subsequently you choose the subscriber, My Subscription, and then device one. And this is the published data via static list that you will see. So over here, this is a real-time status showing you the name that we publish from Modbus or MobiCUA, the values with the actual local timestamp. So this is a proven screen showing us the data is being published, and we can read back from the MQTT broker. Right?
All right.
Yeah, and if we were to use the party MQTT Explorer, we can set up different type of it's not just for showing what we publish on Genesis. You can also connect to other broker from this connection. So you can connect to the Evercom server. You can connect to any of your customers brokers.
Where do we get this MQTT Explorer? Where do we get this?
I just Google and just look for
So
explorers to see MQTT. Yeah, so it will come up MQTT Explorer.
okay, so it's freely available to download
It's
from.
freely alert.
Okay.
Yes.
Okay. All right. Good tool
Yeah.
for testing. Yeah.
Yes. Right. So if I'm connected to my broker, so you see on the left side, my Iconics device one is being successfully published, and I can read the data. So on the right side, you see all the data from my Modbus RAM with the data type, value, timestamp is being displayed in the JSON format. Yeah.
Okay.
So this is another type of display showing the incoming raw message using the multiple message in one multiple area of values. Yeah.
That's good. Thank you very much, Amanda.
Yeah.
So yeah, that's easy to set up the brokers.
Yes.
So do we have a demo setup ready?
Oh yes. So I would like to end my session and introduce my colleague Sudipon, and he will give you a good demo on this MQTT. Thank you.
Thank you, Amanda. Thank you very much for that.
In this video, I will show you how to subscribe data from MQTT broker to Genesis 64 and also publish data from Genesis 64 to MQTT broker. This is the data from MQTT broker, the real-time data on MQTT broker. As you can see, it is array values. The format is timestamp from the server and the values array here. In each set of data, there are timestamps, tag name, and value. I will subscribe this data to Genesis 64. We need to create encoder, MQTT broker connection, and the subscriber. In Workbench, go to Internet of Things. Create the MQTT broker. Right-click on MQTT broker, add MQTT broker. Give it a name, for example, my broker. Select protocol, add simple MQTT, and the server address, that is the IP address of the MQTT broker or server name, and the TCP port. In this case, it is 1883. And use MQTT version 3.1 if need. For security mode, you can setting security corresponding to your MQTT broker. In this case, I have no security credential here. Then hit apply. Now create a custom encoder decoder. Give it a name. And use the message type as multiple values in the values array of message, because my data in MQTT broker is the array. Here, add the message format. This is the timestamp. But my timestamp is not a UTC, it is a local time. Then we need to change the key by adding key and use now local. As you can see, this is the example preview for the key we have selected. And the values. This is the values array. And the value format, it need to corresponding to the original one. T for timestamp, ID for the data name, and the value. There is no status, and I need to change the UTC to the local time. And hit apply. Create the subscriber. Give it a name and choose the decoder that we have created. And select the MQTT broker. Specify the base topic in the MQTT broker. In this case, it is meter data. Following by / and sharp to make sure that we have all of data in that topic. Our device not have the device ID. Then we can use all message will have the same device ID and specify the device ID. For example, meter data. And then hit apply. Now testing with the Data Explorer of Genesis 64. Under my computer, Internet of Things, IoT subscriber. As you can see, this is my subscriber that we have created. And the meter data, the device ID that we have specified here. And the published data via static list. This is the data from MQTT broker. And you can use it on any modules such as GraphWorks. Now I will publish data from Genesis 64 to MQTT broker. We need to create the publish list here. Right click on the publish list and add publish list. In this case, I have the existing one. Give it a name and specify the refresh rate. For example, in this case, 3 seconds. And you can use only send a refresh message and send prioritized message immediately. On the second tab, Publish Real-Time Points, you can add any data tags. This is the publisher name, and hit Apply. If you would like to add more tags, click here to add new item and browse for the tags. If you would like to delete, select Add the Raw and hit Delete on the keyboard and hit Apply. Next step, we need to create the publisher. And the publisher connection branch. Right-click on it and select Add MQTT Publisher Connection. Give it a name and select the encoder. For example, you can use Iconics JSON. If you would like to create the custom encoder, you can create the custom encoder here and then select from the drop-down list and select the publish list. You can leave the client ID. It will be automatically created by the program itself. And you have to specify the device ID and select the MQTT broker. Specify the base topic. You can retain the message. Then hit Apply. Now start the Publisher Point Manager. Go to the MQTT broker. As you can see, this is Gen 64 base topic and the device ID my Gen 64 and the message here. This is real-time data from Genesis 64.
Thank you, Kun Sutipon, for a great demo. We have now come to the end of our MQTT Basics webcast. Thank you for joining us today. Should you have any questions for our team, please feel free to put them in the chat and we'll be most happy to answer them. Otherwise, on behalf of our Iconics APAC team, we would like to wish you a pleasant week ahead and see you soon in our next webcast.